All right, welcome. Today, we're doing something wild. We're going to peel back the curtain on reality itself to look at its secret rule book. Yeah, a rule book for how everything works at the tiniest scales. And let me tell you, it's bizarre, it makes no sense at first, but it is absolutely fascinating.
So let's just dive right in with a question that sounds like it's straight out of a sci-fi movie. What if I told you that reality, our reality, actually has two different sets of rules? One for the big, predictable world we live in every day, and a totally separate, completely weird one for the tiny world of particles. Well, the answer, and this is wild, is yep, it does.
Okay, so first up, two sets of rules. We really need to get our heads around these two competing rule books because they paint a picture of a universe that is just so much stranger than it looks. All right, so here's the fundamental split. On one side, you've got our world, the classical world. Things here are pretty simple, right? You throw a ball, it follows a clear path, it has one location at any given time. Easy. But then you zoom all the way down into the quantum world, and those rules they completely break. A particle, say an electron, doesn't have one single location. Instead, it kind of exists in this haze of all possibilities, all at the same time. And that right there, that forces us to completely throw out the idea of certainty. We have to embrace probability. It's not about knowing where something is, it's more about guessing where it could be, which brings us to what I like to call the quantum guessing game. I mean, it sounds like such a simple question, right? Where is a single quantum particle? If you've got one electron, where is it? In our world, the answer is obvious, it's a single point. But down in the quantum realm, asking where is it is actually the wrong question. The real question is where could it be? And the answer to that question lies in this incredible idea called the wave function. Now, don't think of it as a pinpoint location. Think of it more like a wave of pure potential. It's this mathematical cloud that describes all the possible places a particle could be and also, the chances of finding it in any one of those spots. Okay, here's a great way to picture this. Think about a spinning coin, right? While it's flipping in the air, is it heads or is it tails? Well, in a quantum sense, it's both. It's literally both at the same time. It exists in this state of pure potential, a perfect mix of heads and tails, right up until the second it lands and you look at it. So this whole spinning coin thing, it actually has a name in physics, and it might be the most famous quantum idea of all. It's called superposition, and it is the absolute bedrock principle here. It means a particle, an atom, any quantum system, isn't forced to pick just one state. Nope, it can be in multiple locations, have multiple energy levels, you name it, all at the exact same time. Okay, so a particle is a cloud of possibilities. It's everywhere at once. But what happens when we actually try to look at it to find out where it is? Well, this is where things get really weird. The plot thickens because it turns out the observer isn't just a spectator. The act of looking, it literally changes the game. And this leads us to something physicists call the measurement problem. Okay, so follow this. Step 1. The particle is in superposition, right? It's our spinning coin. It's a wave of possibilities. Step 2. We decide to measure it. We look at it. And bam. Step 3. The moment we do that, the wave of possibilities just vanishes. It collapses. And the particle instantly picks one single definite state to be in. We call that the collapse of the wave function. Seriously, just let that sink in for a second. Because this is one of the most profound and, frankly, unsettling discoveries in all of science. Our observation is not passive. It's like the universe, at its most fundamental level, is waiting for us to look before it bothers to make up its mind. The simple act of measuring forces reality to commit to one outcome. And if you think that's mind-bending, hold on, because it gets even weirder. Now we get to my favorite part, what Einstein himself called spooky action at a distance. We're talking about quantum entanglement. Okay, so imagine this. Two particles can become so deeply linked that they basically share a single existence.
Their fates are completely intertwined. And what this means is that whatever happens to one of them, instantly affects the other one. And it doesn't matter how far apart they are. They could be on opposite sides of the universe. Let's make this simple. We'll use a property called spin. So you have two of these entangled particles, and they fly off in opposite directions. Now, you measure particle A, and you find it has spin up. The second you do that, you know with absolute 100% certainty that particle B, wherever it is, has spin down. It's a perfect, instantaneous cosmic connection.
This idea was so bizarre, it deeply bothered even Albert Einstein. He was the one who called it spooky action at a distance, and he was not a fan. He just couldn't accept that something, some kind of information, was moving faster than the speed of light. But here's the kicker. Experiment after experiment has proven that the spooky connection is very, very real. So, okay, superposition, entanglement. Is this all just weird physics stuff to talk about? Just philosophical head scratchers? Not even close. Understanding the secret rulebook is what's unlocking the quantum future and all the mind-blowing technology that comes with it. And it all comes down to this monumental leap from the classical bit, which is in your phone and your laptop right now, to the quantum bit, or qubit. See, all our current computers use bits. They're like little light switches. They can be on or off, a 1 or a 0. That's it. But a qubit, thanks to superposition, it can be a 1 and a 0 at the same time. And that isn't just double the power. No. It's an exponential explosion in how much we can compute. And that is the real payoff. This is why it matters. This incredible power means we can start tackling problems that are just flat out impossible for even the biggest supercomputers we have today. We're talking about designing brand new medicines, atom by atom, creating encryption that is literally unbreakable, discovering revolutionary new materials. This isn't just an upgrade to our computers, it's the dawn of a whole new era of technology. So, we'll leave you with this final thought. At its very core, reality isn't governed by certainty, but by probability. The act of looking helps create the outcome. And these spooky connections link tiny particles across the entire cosmos. So if our universe is really built on this foundation of pure uncertainty, what does that say about the solid, predictable reality we all experience every single day? That is the secret of the quantum world.